Good morning. I thought I would try to run through one of the questions from your homework assignment that you just finished, like one from each section maybe, and because I know you all will have some questions. So I'm just going to pick a part on this one. So you can fast forward till you get to questions that you need. And if I missed one that you really needed, then just email me and I'll try to go ahead and do this again for you. So theta is 5 pi over 3. You might remember that pi over 3 is 60 degrees. So we're just going to kind of go through this unit circle. There's lots of ways to do this. I'm going to go through by thinking about where my 60 degrees are. Count by 60 degrees. So this is like 60, 120, 180, 240, and 300. So what I really did was I counted by pi over 3s. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 would be right there. So to sketch that, you would just do, your initial side to your terminal side. And that would be a sketch of 5 pi over 3. So on 2.-49, I'm going to get started by looking at the original graph for f of x, and I'm going to make a table of values for some of the points on the graph, just by finding -4 on the x and seeing what its y value is, and then I'll choose one of these others. So this is what my table of value looks like. I didn't get to include all of them because I just kind of ran out of room, and I think the one I'll do is B part, where we're going to have to make a table of values for y equals f of 2x. And the way they taught us to do this the other day was we did x, and then we did 2x, and then we did f of 2x. And we took our original x values that we just had used. And then for this 2x column, we just multiplied them all by 2, -2. And then this column, we wanted to do f of these values, so it was f of -8, f of -6, f of -4. And for some of them, we were lucky because they were on our original chart, like right here, f of -4. So when x is -4, f of -4 was 3. F of -2, when x is -2, f of -2 was 2. F of 0 was 0. F of 2 was 0. And actually, I could get f of 4 by looking at my graph. I just had ran out of room and didn't do 4, but 4 was at 2. So f of 4 is 2. And -6 didn't make it to my chart here, but if you look at the graph, it looks like it's continuing on horizontally. So -6 should also be at 3. -8 should also be at 3. There's nothing for us to assume that it's going to start sloping because it's got that nice horizontal line. And we could look at, if you look at this portion of the graph, you look for from +1, +2, +3, +4, +5, you would notice that the graph is sloping up 1 over 1, up 1 over 1. So we would assume starting right here, if x is 2, we're at 0. So 1 more is 3 is at 1, 4 is at 2. So 5 would be at 3, and 6 would be at 4. Or you can look here and they seem to be going up by 2 in that portion. All right, so here is 50. Using the graph at the right, where is the function increasing and decreasing? Well, for everything that we're going to answer about a function, we're going to use x values, except for range. Range is the y values. And you use x values because x is the independent variable and it can stand on its own 2 feet. So, where is it increasing? Well, let's see, from here to here, we're decreasing. And at this point, we turn and we start increasing. So, we're increasing from this x value forever, right? Because this arrow is going to keep going right and up, right and up, right and up. It's going to keep going forever. So we're increasing from this x value to positive infinity. So that's 0 to infinity. And we always just use parentheses on these. It's decreasing. It starts going down always, like it's from negative infinity, from way out here on this x value. It decreases all the way to this x value right here. So it's decreasing from negative infinity to 0 using x values. Where is the function concave up or concave down? Well, when I look at this function, I only see concave up like a cup. So it's concave up, I think, on the whole graph. It's not concave down anywhere. Does this function have any maxima or minima? Yes, it's got a minimum value right here. Whoops, meant to do my eraser. It's got a minimum value right here. So it's got a min at the ordered pairs at the ordered pair 1, 0. Explain how you know. I know that because, I did my increasing and decreasing wrong. I wasn't looking at my graph correctly. The x value where we changed from decreasing to increasing was 1. This is a 1 here. I'm sorry, I just wasn't looking at the graph right. So I know I have a minimum there because when I look at increasing to decreasing, I am decreasing until 1, and then I begin increasing. So that change from decreasing to increasing indicates a minimum. Okie dokie. Algebraically solve the system of equation and state which method you used. I think I'll do B part for you. So when I look at this system, it's not solved for x or y, so substitution wouldn't be the easiest. It's set up perfectly for elimination because you got your x's, your signs, your y's, your equals, and your numbers, your constants. So everything is lined up great for elimination. And I just would like to multiply this through by a 3 first, just to clear those fractions. So we're going to multiply every term by 3, and I'm going to write the answer down here. So 3 times 1/3 is just a 1x. 3 times 2/3 y is positive 2y, and 3 times 5 is 15. Now, when you look at these two equations, the y's are ready to eliminate if we were to add these equations together. Your book might have called this the addition method, actually, last year, instead of elimination. But because my y's are opposite coefficients, when I add these equations together, the y's are eliminated. So let's add 5x and 1x and get 6x. The y's are gone, and 15 plus 15 is 30. Divide by 6, x is 5. It's one part of your solution. You can go back into either one of these originals and plug in your 5. I'm going to plug it in the bottom one because I don't like fractions. If I can avoid them, I will. So plug 5 in for the x. So 25 minus 2y is 15. let's minus 25 on both sides. And you get negative 2y equals negative 10, and divide by negative 2, and you get 5. The answer is 5, 5. Okay, so for 52, we're going to use the properties of exponents to simplify. The first thing I'm going to do is to look at everything in the parentheses, and if they don't have their exponent written, I'm going to write it in, because the first property I want to use is the power property. And it's when you have a power raised to a power, you multiply those powers together. So we're going to multiply every power times 2, top and bottom. So it's 12 to the 1 times 2, f to the negative 3 times 2, g to the 6 times 2, over 3 to the 1 times 2, f to the negative 9 times 2. All right, I think I'll go ahead and do 12 squared. You could do more things than this at once, but I'm going to go ahead and do 3 squared. Okay, 144 over 9. I don't know if we're lucky enough for that to divide evenly or not. Yeah, we are. 144 divided by 9 is 16. And now let's do the f's. When you divide like bases, you subtract exponents, and it's always the top power minus the bottom power. So, oops, I think I forgot to hit record or resume. So the first thing I did was I gave these numbers that didn't have powers, I went ahead and wrote their powers in. Then I came over here to the side and I reminded you about how a power raised to a power worked. We would multiply. And then I multiplied each of these powers. So I did, goodness, I should just redo it. Completely forgot to hit record. Okay, so it's 12 to the 1 times 2 power, f to the negative 3 times 2 power, g to the 6 times 2 power, 3 to the 1 times 2 power, f to the negative 9 times 2 power. The next thing I'd like to do is work out 12 squared, rewrite everything else, and work out 3 squared. My next step is to see if these will divide or reduce. And since I just did it a second ago, I know it goes in evenly 16 times. And then when I divide these f's, remember when you divide like bases, you subtract their exponents, and it's always top power minus bottom power. So for the f, for some reason I think my iPad paused again, but I have worked this out. I'm not sure where it stopped just a second ago. I did 144 divided by 9 and I got 16. I divided these f's and I did top power minus bottom power and I got f to the 12th. And g to the 12th was positive, so I left it where it was. Our last step was to check our exponents and make sure that none of them were negative, so that we needed to move them to the denominator. Okay, 53. Ling set a goal to ride her unicycle 1 mile, or that's at 5280, 5,280 feet per day. Her unicycle tire has a diameter of 20 inches. How many revolutions will she need to pedal each day to meet her daily goal? So 20 inches. How many revolutions will she have to pedal to meet that goal? Well, 1 revolution is 1 all the way around. That's the length of the circumference. So 1 revolution is found by doing c equals pi times the diameter. So it's pi times 20. So it's 20 pi inches. That's 1 revolution. Well, how many revolutions is she going to have to do to pedal 5,280 feet? Well, the first thing we want to do is probably turn that to inches. Maybe. I don't have my calculator with me, so I'm hoping I'm doing this correctly. So she's got to go that many inches, and she can go 20 pi inches in 1 revolution. So we're going to take the total number that she has to pedal and divide it by how many she can go in 1 revolution. And that should give us the number of revolutions that she'll need to pedal. And if I did my math right, it's 1008.41 approximately. Okay, almost done. A circle is centered at the origin and has a radius of 1. So here's its center, and it has a radius of 1. So we're going to go out 1 this way, all the way around, and we hit that at 1. Swing that radius on around here, we're hitting that at -1. On down here, we're hitting that axis at -1, and back. Maybe you remember the formula for a circle, and maybe you don't. It is this, where h comma k is the center, and r is the radius. So our center is at 0, 0. So we're going to plug 0, 0 in. Our radius is 1, so we'll plug that in. X minus 0 is x, and x squared is x squared. Y minus 0 is y, and y squared is y squared, and 1 squared is 1. So that's a part. If x is a half in the equation you wrote, what is the exact value of y? So if x equals a half in this equation, we're going to do 1/2 squared plus y squared equals 1. When you square a fraction, you square the numerator and the denominator. We'll subtract that 1/4 from both sides. You have a whole, and you're taking away a 1/4 of it. So you have 4/4. Taking away 1/4, like, leaves you with 3/4. Now you need to take the square root of both sides. When you take the square root, you get plus or minus your answer. We're going to separate that fraction to be the square root of both pieces. And lastly, square root of 3 doesn't simplify, but the square root of 4 is 2. Okay, last problem. This is just something to be reminded of, and maybe we have seen it before and maybe we haven't. But these two ways of writing sine squared theta are equal to each other. If you put the whole sine theta in parentheses and square it, it's the same. It means the same as it written that way. Now this means something very different. That means theta is squared, then do the sine of whatever that answer is. So first you square your angle, and then you do the sine of that. So it says if sine of theta is 0.6, and theta is between pi over 2 and pi, including those values, evaluate the following expression or state impossible without a calculator. All right, a part. They want us to do the sine of theta all squared. Well, we know that the sine of theta is 0.6. And when you square 0.6, you get 0.36. So that was fine. B part, they want us to do the sine squared of theta. Well, that is the same thing as the sine of theta squared. So it is exactly like A part. C part, they want us to do the sine of theta squared. Now to do that, that was right up here, we have to do theta squared first, but we don't know what theta is. All we know is theta is in between those values. All we know is that theta is somewhere between pi over 2 and pi, here between these axes, but we don't know where it is. So it's impossible for us to square it and then take the sine. So C part is impossible.